Hello everyone. This video lab report by Divya Talesra, Ishani Kulkarni, and Grace Wang will be explaining the lab called Spacing on CDs and DVDs. To begin with, the objective of this lab is to learn how to use a diffraction pattern to measure the pitch or spacing of the data tracks on CDs and DVDs. Also, by doing this lab, we are attempting to discover whether the DVD data track spacing will be greater, lesser, or the same as the CD data track spacing. In order to conduct our experiment, we used a laser pointer, a CD, a DVD, a protractor, an index card, several pieces of thin cardboard, a sturdy box, a marker, a calculator, as well as a camera. More specifically, this image represents the design of our experiment. We set up the protractor vertically against the graph paper, and we placed cardboard spacers between the graph paper and the protractor, through which we shined the laser. Also, we placed the CD or DVD underneath the protractor, and we conducted this lab with dim lights. To begin with, first we shone the laser on an angle at the CD with it reflecting off the center of the protractor, and we took the following pictures of the protractor with the laser and its reflections on the graph paper. This image is an image from our experiment. It represents the protractor with the laser and its reflection. As you can see, there are clear lines that represent the path of the laser being reflected. We then measured and recorded the angles of incidence and the other observable angles, such as theta sub 1, theta sub negative 1, theta sub 2, and theta sub negative 2. We then repeated the aforementioned steps with the DVD. To gain a clearer understanding of our experiment, here are some more pictures we took while performing this experiment. After using the protractor to measure all the observable angles, we then inputted all our data and calculations into this data table for both the CD and DVD. After recording the values for our incident angles and the other observable angles like theta sub plus 1 and theta sub negative 1, we calculated D for both the CD and DVD and for all our 5 trials. We calculated D for when m equals positive 1 and for when m equals negative 1 by using the following formula. D equals m times lambda, where lambda represents the wavelength of the laser we used, all divided by the sine of the theta sub m minus sine of theta sub I. By using the formula listed above, we calculated the values of all our D's. Then we calculated the average of all of our obtained values for the variable D. For the CD first, we got that the average values for D when m equals 1 is 1538, and the average value for D when m equals negative 1 equals 1581, with the units being nanometers. The overall average was 1560 nanometers. For DVDs, however, the values we obtained for D when m equals 1 and when m equals negative 1 were much less. Specifically, when m equals 1, we got D to be 711 nanometers, and when m equals negative 1, we got the value of D to be 714 nanometers. Thus, the overall average for the D value for DVDs we got to be was 713 nanometers. By using the formula D equals m times lambda divided by sine of theta sub m minus sine of theta sub I, and the collected data on the measures of the angles, we concluded that the average pitch for CDs is about 1560 nanometers, while the average pitch for DVDs is approximately 713 nanometers. Evidently, the average pitch for CDs is about double that of DVDs. The DVD data track spacing is much smaller than the CD data track spacing, probably because CDs do hold much less data. In fact, about half the amount than DVDs do. Overall, this vast difference is due to the vast difference between the pitch of a CD and the pitch of a DVD. Some things to keep in mind are that the value to the placement of the index card relative to the disc is extremely sensitive, because if the measurement is not along the diameter of the disc, but instead along a chord, you would get a completely different value for the track spacing. Specifically, if the index card is slanted, then the pitch distance will increase, since the diagonal between the pitch length and the width are also being accounted for in the measurement. Furthermore, just to clarify, whether you use a green laser or a red laser is not important, because in the end you will get the same value for D. The type of laser you use is independent to the value of D you will get in the end, because depending on which laser you'll use, you will get different values for the wavelength and for the measured angles. However, when plugging those values back into the formula, you will still end up with identical or about identical values for D. Thank you so much for watching this video, and I hope you learned about the spacing on CDs versus that on DVDs.